This is the Lone Crater YouTube. We hope this video helps.
You begin by preparing a reproducible environment. Install a stable Linux distro, JDK 11, repo and Git, Python 3, and ensure 100 plus GB free. Clone the AOSP manifest or a base ROM manifest for your device. Once done, sync only the branches you need to save time. Grab the device tree, kernel and vendor blobs from the manufacturer or trusted sources because those pieces tie hardware to the build. Make sure to enable Ccache and add your SSH keys to speed up fetches and reproduce builds reliably. You now configure and compile. Source build /and setup. SH and choose your target with Launch Device User Debug. This sets tool chains and flags. Apply device-specific patches and merge vendor blobs, adjusting build. Prop and SE Linux policies so services start cleanly. Once configured, run mka bacon or make $nproc to parallelize compilation. Watch the output for missing symbols or failed modules. If a kernel module fails, rebuild the kernel with the same GCC version used for AOSP to avoid ABI mismatches. This is why toolchain consistency matters. You finish by flashing your ROM. Unlock the bootloader, then flash boot, system, and vendor images using fastboot or a DB sideload. Once done, perform a factory reset to avoid user data conflicts. Boot and run core tests, Wi-Fi, cellular, camera, sensors, because hardware integration is the usual failure point. If something breaks, collect logs with a DB logcat and dmesc, identify the failing module, and rebuild just that component. This iterative fix and flash loop gets you a stable ROM faster. One key tip: verify kernel and vendor ABI versions when you hit boot loops.
Thanks for watching. Consider subscribing if we helped you.